In this lesson, I want to go over a basic introduction to exponents, basically looking at where they come from and what they're actually used for. And then later on, we'll go into a bit more of an expanded discussion of the different properties and rules of exponents. But for now, let's just see where they come from. If you think back to arithmetic, you remember that if you're being asked to do addition, and you're being asked to add in a repeated fashion, for example, like 5 plus 5 plus 5 plus 5, that a shortcut for handling this type of addition is to simply change it into a multiplication problem, which in this case it would become 5 times 4, which is much easier to do mentally and much shorter to write, and is just 20. Now if we step forward and think about an occasion where we might be asked to multiply the same number by itself repeatedly, then that's where exponents come from. An exponent is just another way to write something, or a number or a variable that is being multiplied by itself repeatedly. In an exponential expression like this, we have two very critical parts. First of all, in this case, the 5 is the base. The 5 is the number that's being multiplied by itself, and the 4, which the role it plays is that of the exponent. The 4 is just telling us how many times that 5 should be multiplied. Now, a common mistake to avoid is to think that 5 to the 4th power is the same thing as 5 times 4, because that's simply not the case. As we can see up here, 5 times 4 is 20, but 5 to the 4th power is not, simply because when you multiply 5 by itself that many times, it becomes much larger than 20. As a matter of fact, this might be a good opportunity to jump to the calculator and see just how big that is. We have a key on the calculator right here that's called the caret key. And the caret key is the key that you use when you want to raise a value to a power. It's a very powerful key. It can raise constants to powers that maybe you haven't thought of before, but that you'll be seeing in the future. So let's take a look at 5 to the power 4 and see just how big that is. And as you can see, it's a lot bigger than 20. 5 multiplied by itself 4 times would give us 625. Okay, and again, the way you do that, if you were to attempt to do it mentally, would be 5 times 5 gives you 25, times 5 again is 125, times 5 one more time, and that is where the 625 comes from. Now when you write something in exponential form, you have to remember that these exponents are, well, they're very literal. Alright, so if we had, for example, this expression versus that one, we might ask ourselves, well, what's the difference? And I'm not even saying what the expression is, we're just going to write it out. And they look to be, except for one having parentheses and the other one not having in parentheses, they look to be the same. But again, we can go to the calculator and see what the difference might be. Alright, now the first one, we had no parentheses. And notice we have a square key here. If you're raising something to the second power, there's a shortcut for you to use. But in this one, our answer turns out to be negative 4, so we can go make note of that. This one turned into a negative 4. Now the other one, let's see what happens there. When we use the parentheses and put the negative 2 inside of them, and then square, we get a positive 4. So we want to come back over here and make note of that. And we need to think about why we got a negative 4 one time and a positive 4 the next time. And the reason is basically because in this first example, the square is only on the 2. It's not on the negative. In other words, this is the same thing as a single negative, or think of it as a negative 1, being multiplied by a pair of 2's that's why it turns out negative. In the second example, where the parentheses were present, the negative will be squared along with the 2 because it's in parentheses, and that's the reason for the positive result. And other examples that we could look at, if we had, for example, negative 2 to the third power versus the opposite of 2 to the third power, I think we'll find that on the calculator this time that negative 2 to the third power turns out to be a negative 8. We'll also find that negative 2 to the third power, when written with the parentheses, also turns out to be negative 8. But there are different reasons for this. The first example is negative 2 multiplied by itself 3 times. The first two negatives cancel each other out, and you get a negative 8 result because of the last negative. In this other example, you have a solitary negative, and then you have the 2 3 times, but since there's only one negative, there are none to cancel. Get the same answer, but for a different reason. So with your negatives, when you're using either the calculator, make sure you remember to use the parentheses when they should be used, and when you're working it by hand, make sure you understand what happens with these negative signs. Now another thing that we should look at is what happens when we start taking a fraction and raising it to a power. They are actually easier to work with than what you might think at first. If I had a 2/3 to the third power, what that third power is implying is that I need to take the 2/3 and multiply it by itself 3 times. Now as you remember, when you multiply a fraction, you multiply straight across the top. So 2 to the third, 2 times 2 is 4, times 2 again is an 8. Now for the 3. 3 times 3 is 9, times 3 again is a 27. What we actually find then is that when we raise a fraction to a power, we can simply raise the top to that power, raise the bottom to that power, and that's a much quicker, easier way to handle it. And again, watch your signs carefully. If I have a negative 1/2 to the fourth power, the first thing I would look at is my sign. I know that a negative multiplied 4 times is going to come out positive, so I already know I'm going to have a positive result. 1 to the fourth power is going to be 1, and 2 to the fourth power, let's see what that's going to be. 2 times 2 is 4, times 2 again is 8, times 2 once more. 1/16 is going to be my result on that particular multiplication. Now we need to think about with our exponents where they fit into the order of operations. And the way where they go, well, let's just go back over this real quickly. Order of operations says grouping symbols first. That would include your parentheses, your brackets, even includes your absolute value. Alright, so grouping symbols come first with your order of operations. Second, with your order of operations, that's where the exponents come in. So these exponents that we're working with are second on the list as far as what you work with your order of operations. Alright, so if we were to look at an expression that contained exponents and were to work it out and evaluate it, then this would come right behind your grouping symbols. So let's take a look at a 5 square plus 7 minus 2 cubed. Okay, so the first thing order of operations says is going to be your grouping symbols. So we'll hold off on the 5 square, we'll hold off on the cubed, and we'll do 7 minus 2 first, which is 5. Now, for your exponents, 5 squared is 25, And 5 to the third power is a 125. And when you add these, you get 150. And again, on the calculator, if you can simply get it typed in the way it looks on paper, your calculator knows the order of operations and will follow them. So we could come over here and we could type in 5 squared plus, and you put in your parentheses, 7 minus 2, close parentheses, caret for power, then you put in the 3, and the calculator agrees with what we said as far as that answer is concerned. So that is your basic introduction to exponents, and like I said, later on we will take a look at more detail as far as the different rules of exponents are concerned.